Yes, hello. Good morning, everybody. Wherever you're coming from, please let us know where you're joining us from. We love to see the global OpenCV audience chiming in every Thursday morning. I am coming to you from beautiful, fragrant Soma in downtown San Francisco, California. And our guests, Paula, where are you joining us from, Paula?
I'm in North Carolina, USA, and hello and
Right on.
hola para todos mis amigos que hablan español.
Hola. Next, Ashwin, where are you coming from?
I'm actually in Netherlands. This is the north of Netherlands.
Right on. Samet, how about you, buddy?
I'm from Durham, UK, North UK.
Your accent really comes out when you say place names. It's delightful. Lars, how about you?
We're here in Munich, Germany.
Right on, man. This is a real international episode here, and we've got Jan Hendrik. Is that
Also
correct?
Munich, Germany.
Right on, right on. Wow, in the chat, popping off already. We've got Kolkata, India. We've got the Bay, Seth for the Bay. We've got yes, of course, Paula, North Carolina. Got more India, Grenoble, France. Again, I'm always have to give a shout out to the home of the late great Andre the Giant, Andre Rusimov. Johannesburg. We've got Baja, California. We've got Nigeria, Kenya, San Ramon, California. Yes, indeed. Let's check out the chat. We got over on YouTube. There's about 20 people watching over there. We love to see it. Trying out the format with the Brady Bunch here. We'll get started in just a few moments, but yes, please drop in the chat where you're joining us from. I see Pakistan over on YouTube. We are, as we've mentioned the last couple of weeks, we're fully monetized on YouTube now. That means that you can become an OpenCV member on YouTube for just $2.99 a month and support open source computer vision. I will do a little shout out to our current members later on in the episode, right before our trivia challenge. We'll get started in just a second here while I push the cough button. I know, thrilling television. So we've got George from Arizona checking in on YouTube. We've got Indra from South Korea. Love to see it, folks. I think now is a good time for us to get started here. Hey out there, everybody. It's me. It's that PHI-double-L-I-P. I am your co-host with the co-most, the second banana, who is second to none. I'm also your plus one and only. It's Mr. Nelson. If you're nasty, but you, my dear friends, can call me Phil. And I'm here on this beautiful Thursday morning to welcome you to OpenCV Live, episode 171, if you can believe it. It is a Thursday once again, as the late great David Lynch would have said, and we have a blockbuster episode here. I think this is the most guests we have ever had for a single episode of OpenCV Live. We got five, count them five, count them five, count them five, count them five guests here today, and we're pleased as punch and happy as a clam. I've got to remind you of a couple things we're doing here before we get started, though. The first of which is a giveaway to you in the audience. Later on in the episode, I will be asking a single trivia question based on what we talk about here today, and the winner of that trivia question, the first person to answer it correctly in the Zoom chat, will win the OpenCV University course of their choosing, or, if you're in the Bay Area, one free pass to OSCA, the OpenCV SID Conference on Computer Vision and AI, which I'm going to talk about just a little bit here at the top of the show. We got some business to take care of, as Dusty Rhodes may have said. OSCA is OpenCV's first ever conference in our 25-year history. We are super duper excited about this. I am so anxious, I'm practically vibrating, but it's going to be a lot of fun. This Monday, May 12th, we are taking over the San Jose Convention Center for one day of community and talks from OpenCV and industry leaders. You can go over to Hackster and check out the full speaker lineup. Find yourself a 20% off a discount code over on the Hackster article, which I will be posting in the chat here. You can see people talk such as our own Gary Bradsky, founder of OpenCV, Dr. Satya Malik, the CEO, Kwabena Agyeman from OpenMV. For some reason, the photos are not loading here. I don't know what's up with that, Ginger. Ted Larson, Overlog, Steph OK. We've probably in the chat right now. Kartik from Intrinsic. the head of perception over there, the homie Joseph Nelson, no relation from RoboFlow. We've got Perena from Voxel 51 as well. Jose Benitez, a great OpenCV University success story. You can go to the OSCA website right now and sign up. It is $4.99 normally, but with that 20% off code, you can save yourself quite a few dollars. It's one day. You won't forget it. Please join us. It will be a lot of fun. Before we get started, again, OpenCV is a nonprofit organization that puts out an open source library, and as such, we need your help. I just want to give a quick shout out and thank you to all of OpenCV's members and partners. We really could not do it without them, and thanks to all of you for watching this show, because we couldn't do this without you either. So, Paula, what do you got for us today?
Okay, that's great, Phil. So first of all, thank you so much for this invitation. This is not the first time in the show, it's the third one. So the first one I was with maybe four guests there. So then I was with Summit, and now we are, the full team here together. So we are so excited to share what we have for today. So let me share my screen. Can you see my screen?
Looks great.
Perfect. So, we want to impact people, this is impact researchers and also the industry. And we are part of the organizers of the Anomaly Detection Challenge at CVPR. And this is the third challenge that the workshop has. So basically, we try to join forces and co-organize this with MBTech, Anomalib, and Voxel 51. And we will be live in June the 12th in Nashville, Tennessee at the conference. You will
Yes,
be there.
indeed.
You will be there. So, Bill?
Yes, OpenCV will be there. We will have a booth once again. We've got some new stickers and swag that we'll be bringing to the booth. The I Love OpenCV sticker will be available for free at the CVPR booth. Also, we are doing a little something with our friends at Ross. We will have some kind of meetup there in Nashville, so stay tuned for that. Best way to find out is the OpenCV newsletter.
That's amazing. Also, we have a lot of stickers as well. So I don't know if you can see that. But also we can provide some stickers and swags. We will have the booth there as well. So we are so excited. And the human beings behind these judges and organizers. So Samet, Dick, Ashwin, Lars, Jan, and also Ula, and myself. So in this effort won't be possible without these people. We have been working so hard since the last CVPR, try to organize this and improve the experience for developers. So let me jump on this. So they have the workshop. If the people is interested to see what the workshop means, they can scan the QR code and they can see all the grill of speakers that we have for the workshop. That will be a half-day workshop on June the 12th. But also they have the opportunity to watch this virtually with Zoom. So we have a great workshop statistics here. We can see a lot of attendees, full room. We didn't see an empty seat last year. We have over 200 people participating in person and online. And we have also, last year, we saw a lot of people registered to the challenge, more than 400 registrations. At the end, the conversion rate we received 220 submissions, and that was a huge effort from Summit's team to evaluate those submissions. So part of the things right now is, so we are more people. We have also the support of MBTech, and we will do exactly the same thing that we made last year. So we will work on how we can adapt the state-of-the-art anomaly detection algorithms for simple anomaly detection, and also how we can improve the few-shot learning with anomaly detection. So you can see that today. And we have basically two categories here. So the category number one that Lars and Jan will talk about that deeper. We want to adapt and detect with robust anomaly detection in real world applications. So in the category 2 that Samet and Ashwin will talk about, that is how we can use VLMs and use few-shot learning for logical and structural detection. And this is a really, we have like for beginners and also for the advanced developers. So, and we are so excited because we can see a lot of people, we can see right now a lot of submissions. We already have leaderboard for both categories. So the challenge started on March the 15th. We launched the challenge March the 15th. The challenge officially started April the 7th. And people will have until May the 26th to submit the solutions. So if you want, you can register to the event. Just scan this QR code, you can fill the form, and you will receive updates about the challenge. Updates in the leaderboard, updates in the data set. Please scan this QR code and you can register to the event. But also you can join our community. We at Voxel 51, we create a specific channel that we can communicate with the participants. You can also scan this QR code. We have this Discord channel where we have fluent communication with participants if you have any questions at any time. So we will be there for answer those questions. So basically here, and also one of the main things that we can see in the industry and is a big challenge is that we don't have data sets at all in the industry because everyone has some top secret stuff. And I think that I want to recognize the effort that MBTech is doing, providing some open access data sets to researchers. And that is fantastic that we can have these kind of data sets to test, to improve, to train models for anomaly detection. So, but the main gap, and Lars will talk about that. So the main gap that we have with those data sets is maybe those data sets were not super close to the reality, and we were missing maybe some variations, lighting conditions, blurry images, or some variations in the objects as well. So we will work with this new data set that MBTech provide. MBTech also launched this data set at the time that we were launching the challenge as well. That was great. And this is for the category number 1. For category number 2, we will use also an MBTech data set that is a local AD, that is for logical and structural detection. And Samet and Ashwin will talk about that deeper. So I want to pass this over to Lars and Jan. So I'm so excited. If you have any questions, I can answer those questions in the chat.
Yes,
Right.
and please introduce yourself a little bit briefly before you get started. Everybody loves to know who they're talking to. Also, a quick reminder, OpenCV also has a workshop at CVPR this year with our friends at Intrinsic. It is the Perception for Industrial Robotics Automation. That is June 12th. It's a part of our perception challenge for bin picking. We will have the winners of that. It's going to be a really good time with some really awesome hardcore science going on there.
Cool, sounds great. Okay, then let me quickly introduce myself. Hi, my name is Lars. I'm a PhD student with MBTech and the Technical University of Munich. And surprise, my PhD topic is on industrial anomaly detection. I've joined MBTech like 3 years ago, roughly. And yeah, I'm really excited to co-organize this challenge together with Paula, Ashwin, Samet, Jan, and also our colleague Ulla. Yeah, I don't know, Jan, do you want to introduce yourself as well right now?
Hi, my name is Jan. I'm also with MBTech for 5 years now. I'm also working in the research department. I did a lot on OCR, synthetic data, and recently also anomaly detection.
Yeah. Okay, then I would say let's dive right into it and talk about track 1 of this year's Anomaly Detection Challenge at the VAND workshop, which is Adapt and Detect on robust anomaly detection in real-world applications. Paula, can you go to the next slide or should it take control? Yeah, let's do it like this. So first things first, what is anomaly detection actually? So before coming to the actual content of the challenge, I would like to briefly introduce what anomaly detection is. So anomaly detection is the task of detecting and localizing defects. As you can see here on the slide, let's take the example of some capsules. There might be some good capsules that are highlighted in green here that do not have any defects, that are okay. But there might also be, of course, some capsules that are damaged and they have defects like cracks in the upper row or like scratches, dents, or some color defects. Exactly. And the task of anomaly detection is to detect these defects, to say, okay, this is a good sample, this sample is anomaly free, or this sample contains an anomaly. And furthermore, to localize the defect. So to tell us where is the defect in the image. And if you could go to the next slide, exactly, Paula, thank you. What we would expect from an anomaly detection system, if we give it an anomalous test sample as an input, we would expect it to output such an anomaly map, which indicates where the anomaly occurs and if there's an anomaly. So usually these anomaly maps are continuous maps, so kind of heat maps. And in this case, these are values between 0 and 1, and higher values usually indicate the presence of an anomaly. Vice versa, if we see an anomaly-free test sample, we would expect our anomaly detection system to behave like this, so to output an anomaly map which does not indicate any presence of anomalies. So I don't want to go too much into the details here, but I want to briefly introduce how anomaly detection systems are usually trained. We're talking about the one-class training paradigm, or also we call it unsupervised training for industrial anomaly detection. And unsupervised training for anomaly detection means that we only use anomaly-free data to train our model. And the reason for this is pretty straightforward. Imagine you have a production line and you want to detect anomalies, but yeah, what are the anomalies? So you don't know which kind of defects can occur until you launch your production line, actually. So what you do is you take images of your anomaly-free samples to model the distribution of normal data as good as possible, and then later at test time, you try to compare your test samples or your test images to this distribution you've seen during training. And so we just trying to learn what the distribution of normal data looks like.
Yeah, thank you, Lars. Yeah, we have seen a lot of development in anomaly detection the last couple of years, and we also see that existing benchmarks like MVTech AD or Visa are starting to saturate. And this motivates us to create the new MVTech Anomaly Detection 2 dataset and also the benchmark server. The first main challenge we see is intra-class variability. Maybe Paula, you can go to the next slide. Yeah, thank you. And also in the production setting, not everything is fixed and nice and constrained. But for instance, in the food industry, you have like different appearances of objects and the placement vary greatly. And here you've got an example of the fruit jelly object, which is like a jelly inside a plastic cup with different kinds of fruits inside. And you can see here that the jelly, the color differs quite a lot, and also the kind of fruits which were used differs. And the challenge for the anomaly detection system is here to differentiate between the normal variability and being robust such that you can still determine the actual defects. And you can see here the defects in the next slide. It's like a small metal contamination in the second image and an alien object which is infected, a small pickle in the last object. And so we added a lot of objects with high intra-class variability to challenge the systems. The second challenge is to improve the localization quality. If you have worked with anomaly detection, you know that the localization is key. And you not only want to determine whether a sample is good or bad, but also to localize the defect, to accurately localize it. And on the one hand side, this increased the trust in the system such that you can understand why the system did the decision. And on the other hand side, it's also possible to debug the production line such that you can determine the root cause of the defect. And in our MVTech AD2 dataset, we focused mainly on very small, subtle defects, which are hard to define. And also, we introduced very strict limits in the evaluation platforms to penalize systems and anomaly detection setups, which tend to over-segment. The third challenge is threshold estimation. So in general, as Lars mentioned, anomaly maps anomaly system outputs those continuous maps. But in practice, you want a strict binary decision whether a pixel is good or bad. And this last step, the threshold anomaly maps, is often overlooked in practice and in literature. And therefore, we challenge our participants to upload also thresholded maps and focus on evaluation metrics that require those thresholded maps.
All right, then I'm going to talk about the last two challenges we currently see and that we incorporated in our new data set. Track one of this challenge is about robustness, as said in the beginning. So we also try to measure the robustness of a method against changing environmental conditions, like changing lighting conditions in this case. So what we did when creating this data set, we captured every scene that we captured under different lighting conditions, under the regular lighting conditions, we call it, and under at least, I think, 4 additional lighting conditions. So we might have the same scene which is slightly underexposed or overexposed, or we also installed additional light sources. And then to test the models against these changing lighting conditions, we created 2 test sets. So the first test set, it contains picked images that were captured under the regular lighting condition, and this regular lighting condition is also seen during training. So all training images are captured under the regular lighting condition, and the first test set also as well. Then we created another data set where we mixed the different lighting conditions, still the same scenes, but different lighting conditions, so that we can really nicely compare the performance of the model on the data set with the scene lighting conditions and the test data set with the unseen, with the mixed with the mixed lighting conditions. Yeah, and by comparing the performance on these 2 test sets, it allows us to evaluate how robust the model is against lighting condition changes. Yeah, the last point is really important. I think you might be familiar with it if you have some industrial background. Let me put it like this: speed simply matters. So your anomaly detection system might perform really well. However, to be deployable in practice, you also have to consider the memory footprint of your anomaly detection system or also the inference runtime. The production rates in modern industrial lines are that high that really fast algorithms are usually required. And furthermore, some defects, I think Jan also talked about it, might be so subtle and so small that you really need to capture high resolution images just to be able to see them. And when we investigated state-of-the-art methods on our new data set, we saw, okay, if we increase the input image size, some defects might become visible after all, and you can increase the performance. This is what you can see in the plot. However, at the same time, it's no surprise, the inference runtime and the memory consumption also increases. So we just want to raise awareness for this fact that your algorithm, of course, needs to perform really well, but also has to consider the industrial requirements to be deployable in practice.
That sounds great. So I think that I have one question is, one note here is anyone that wants to participate on this, they can do it. You don't need to be part of CVPR. So this is also open to people out of CVPR. So that would be great if you can be at the workshop and can attend that, but it's not mandatory. So if you have the interest to participate in that, so please go ahead and register and make your solution. Sorry, Lars, go ahead. Sorry.
That's all right. Really good information. So yeah, we try to incorporate all these challenges, all these 5 challenges we currently see into our new data set, into this design of our new data set. And then luckily, yeah, we met with Paula and Samet and the whole team and to create track 1 of this year's Anomaly Detection Challenge at CVPR. And so we also set up an evaluation server, a benchmark server, benchmark.mvtech.com, which is our submission platform, where you can easily participate in track 1 of the challenge. And I don't know, Paula, if I should talk about the submission process right now, or if you want to go ahead first.
Yes, let's do a break here. So I think that we have a question in the chat field. Yes.
Indeed, we do. I see one from Tiana here. It says, what is the acceptable error ratio before deployment for this?
This, maybe I can take this. This depends on the use case. So like whoever is deploying like a company or whatever, they set the requirement, say, hey, as long as I'm above 90% accuracy, that's fine. But some customers or companies might just say, oh, I don't have any, I have to have like 99 plus performance, otherwise this just won't work. So we cannot specify a fixed rate on this. It depends.
Thank you, Samit. I think that's all right. So let me jump to explain a little bit what the data set looks like. I think that then after that, we can explain the benchmark and the submission platform, right? Okay, perfect. So you can explore the MBTech ID too, and you can scan this QR code and you can see a notebook to explore this data set. So basically what I was doing here, or I'm doing here is opening this data set in 51, that is the application that we have at Voxel 51. So let me, I will show you how this is working. So 51 is an SDK, but it's also an application. So here, basically, I already run this notebook that you can scan with the QR code. And you can open all the categories that MBTech AD2 has and explore what that means, what those shifting means as well, these variations. So you can explore quality of the images as well. You can explore if the data sets are balanced or not. Normally in anomaly detection, you don't see balanced data sets. So you can also see that here. So let me show you how this is working. So basically what I have here is the MBTech AD2 data set. As you can see here, we have a menu in the left side where I have the categories. So I can visualize different categories. So I can see here fabric, rice, can, fruit jelly, walnuts, vial, sheet metal, and wall plugs. So let's go with vial, for example, and let me reduce the size of this and we can take a look of everything. So I'm just selecting vial here, and I can also define if I want to see a specific defect. So I have good and bad. So, but maybe good and bad is not enough. We are also talking about that we are shifting this, that we have more information and variation. So we can also see if this is a regular image or if we have any kind of overexposure, or we have this different kind of shifting. So, and this is great because you can take a look of, for example, shift 2, or you can take a look of the overexposure, for example, and you can take a look of that. So with 51, just let me just show you everything again. So with 51, we have the capability as well of, let me show you with a dashboard. So here we have different panels, and those are interactive panels that you can play with your data set. So basically, I want to create a histogram, a categorical histogram, and I want to call this, for example, MBTech AD2 his, and I want to see all the categories that I have in this data set. And I want just to have this view all time, and I want to create this plot. But I can split this, and I can interactively play with my data set. Okay, I can see can, fabric, fruit jelly, rice, sheet metal. So let's come back to vial. So I just click here over this bar, sorry, and I can see all the information that I have there. But what if I want to see what is going on with this specific data set? Or this specific category, I can add another plot. So I can add another plot, for example. I can add another item, another histogram, and I will call this like a vial histogram. And I want to see the defects, or I want to see the shifting process that I have there. And I want to create this plot. And I have, as I mentioned before, it's super difficult to find balanced data sets in anomaly detection. So, but I can click here in the overexposure. I will click over the bar, and I can see just the overexposure information. So you can navigate this data set, you can take a look of what is going on, and you could have an inspection before you can deliver or train your own models. Also, 51 has the combination, the integration with different kind of training frameworks, but also we have some examples of 51 working with Anomalib. So, and I will paste that in the chat. That is an amazing integration that we have as well. So, but this is not just that. So I don't want to take too much time on this, but let me just come back to my original data set here. And I want to see embeddings. I can see what kind of information I have here. I already calculate the embeddings using OpenAI Clip model. And I already create my brain key, and I can see that I have these embeddings. And this is also an interactive plot. So I can color this by category, for example. I will say, okay, I want to color this by category and say I want to see category label. And I can see the clusters. But I can also understand the overlayers that I have here. For example, I want to take a look of this point that I have here. And this is the overexposure vial information. You can take a look of these clusters that you have. Maybe here, this is the same category, but we have different shifts there. So this is the metal sheet that we have. You can explore, you can take a look, and there are a lot of stuff that you can explore with 51. So I will also recommend you can scan the QR code and try this by your own. This is, you need to download the MBTech dataset from MBTech webpage, and that's all. You can run this locally. You don't need to subscribe. It's just pip install 51, as I have here. Pip install 51. Okay. I will pass this over to you, Lars.
It's almost as easy as CV2. Almost.
It's almost. I think that is the same. I think that we can make something cool together, Bill, because we are super easy to use.
Yes, absolutely.
Or if you're using Anomalib in your notebook, so if you import MVTech2, it'll automatically download that as well.
That's true.
Very nice. Very nice.
Okay, this is great. So I think that we have more stuff to talk about. Lars, over to you.
Yeah, thank you, Paula. Nice visualizations and a nice tool. Yeah, it's really cool that we all work on this together. Okay, so we'll briefly talk about the submission process for track 1. Hopefully this won't take long since it's so easy. Let's see. So you just have to go to benchmark.mvtech.com and create an account, either via the submit button or the login button. And then after you created your account, you can directly go to the submit page, which we can see on the next slide. Yeah, and there is all the information you have to insert for becoming part of the challenge. So of course your method needs a name. It's important that it starts with VAND 2025. It's just an identifier, so you can change that anytime until the deadline of the challenge. Finally, you have to provide you have to open source your code. So for example, a GitHub repo, and also you have to provide a technical report to your submission. I think this is quite similar for track 2, but I guess Summit will talk about this later again. And yeah, what's most important, of course, it's your model predictions or your model's prediction. For submitting to the track 1 of the VAND challenge, you don't have to upload your whole model. You just have to upload your predictions. So the test set or the data that Paula just showed, it's a public test set, but on the submission platform, there are 2 private test sets. So for these private test sets, you only get the image data, you only get access to the image data, and the ground truth is only accessible via this via our benchmark server, such that it's harder to cheat and yeah, harder to see the anomalies in the private test set to become to be as close to real world applications as possible. We're really excited that we received, I think, as of today, over 50 submissions for the challenge alone. Yeah, really excited to see the progress that's currently ongoing, and also excited to see how far we can go in track 1.
Okay, so this is great. Thank you, Lars. Thank you, Jan. This is a great effort, having this submission platform in a challenge, in a hackathon is super hard. So we try in the past with different challenges to use different kind of systems. It is great that MBTech is providing support to receive and evaluate those submissions. So the leaderboard is, I have a question, maybe something that people need to understand. Is the leaderboard updating daily automatically when I have the submission there? So how long they need to wait to see the result in the leaderboard, Lars? How long
I
is
think
that?
the evaluation is about 10 to 20 minutes, and then you will see your result in the leaderboard directly.
That's
It's
perfect.
live.
Thank
Yeah.
you. And also we have the leaderboard in the website of the official website of the challenge. So all the leaderboard there is updated. That's great. So I want to pass this over to Ashwin and Samet to talk about the advanced category that we have in the challenge. They are working also so hard to prepare the submission platform with a different style because the challenge is different for this category. But it's, the stage is yours, Ashwin and Samet.
I'll leave the floor to Ashwin shortly, but before diving into category 2, I would like to talk about category 1 a little bit. But for more like a high level, I know this is not planned, but let's make this natural. So I was talking to a colleague of mine today, and having a discussion about like what is the biggest problems in AI and stuff, and in terms of also the challenges and the revenue and stuff. When you look at it, there's so many interesting and exciting things going on, right? All the Gen AI stuff, fancy image generation things, and all the cool stuff you see everywhere. But when you look at the like challenges and the revenue-wise things, vision is still number one task. And within vision, object detection is one of the top tasks, followed by anomaly detection. So there are like reports, business reports about this. So anomaly detection is super important, especially in industry. So that's like the high level overview, maybe for those who are not familiar with this field. Within this, this is a challenge we hosted last year as well. And then we're hosting the same challenge this year as well, mainly because we think there's still quite a lot of room for improvement. So this is important. And Lars and Jan introduced a really challenging and great data set here. And I'm super excited about this because, I mean, kudos to MVTech folks. They released amazing data sets with thanks to the first version of MVTech dataset, the literature, there's amazing papers out there. We're super excited. We even had quite a lot of demos, even at CVPR. But as Lars and Jan mentioned, many models, performance of those models are kind of saturated. So a lot of papers out there, they claim that, oh, we have 95%, 99% performance. But when it comes to the deployment, that's quite problematic. Even Paula, like for example, at 2 years ago at CVPR, she's having like this great demo with a robotic arm, doing anomaly detection, picking up the defective cubes on the conveyor belts and stuff. So she was training one of the state-of-the-art anomaly detection models, and as the day changes with the daylights, from morning to the afternoon, she was like, oh my god, the performance is not great now because the lighting condition is changing, or like someone is just touching the lights, and then she's like, don't touch that because the lighting condition will change and the performance will drop massively. All these sort of things. So in the industrial product line and stuff, we have this problem as well. So this data set, the Lars and Jan and the rest of the MVTech folks introduced, this is a really challenging data set. Hopefully, we'll address all these problems, and we will have much better models addressing all these issues in real-world settings. So I wanted to mention this first. So,
Well said, Samet. That's amazing.
Thank you.
Thank you.
Yes, thanks for that.
Yeah, so the second challenge, I mean, that's not the only challenge that we're having. So this MVTech 2 dataset introduces a quite challenging anomalies with small defects and different lightning conditions and all that stuff. But again, kudos to MVTech folks. They released another data set called LOCO, which is about logical anomaly detection. Maybe if we can move to the next slide, we can talk about it. Right. We had this, I think we asked a similar question last year as well. So like, what are the defects in this? So what can you tell about the defects in this image? Maybe we can have some guess. Right. Okay. So maybe we can.
I know the answer. May I say that?
Yeah. Go ahead. Go ahead. Yeah.
So one screw is shorter than the another one.
Yes. But yeah, it's yeah. We have two washers, one short screw, one long screw. Yeah. We just move to the next slide. Yeah, so there is a missing short screw. So the previous slide was the anomaly-free image, right? So that was how it's supposed to be. So this one, there's two long screws, but not a short screw. So the concept here is that we are looking at the logical defects rather than the structural defects. What do I mean by structural defects? If you look at the right-hand side figure, so there's like a broken short screw. So that's more like a structural defect, right? So there's both structural defects and logical defects that we're interested in this challenge too. So it's conceptually, it's a bit different. So two different problems, two challenging problems. We're trying to solve this with utilizing vision language models, which are quite hot topic these days and months, as everyone's aware. Yeah, so this is basically challenge 2. I'll just leave the floor to Ashwin so that he can talk about the submission platform and how we followed a unique approach here with the submission platform, and so yeah, floor is yours, Ashwin.
All right, mandatory. Can you hear me?
Yes.
All right, perfect.
Yeah. Before, sorry to interrupt you, Ashwin. I need to introduce Ashwin. He's one of the guys behind Anomalib, and he's super smart. And he's usually behind the scenes working, hard coding, all the cool stuff with Anomalib. I just wanted to say that. Kudos.
Yeah, thank you. Yeah. All right. After I'm done blushing, I'll probably start with the platform. So last year we had a couple of feedback actually. So one was because we had to run each of the submissions manually, it wasn't transparent for a lot of participants. At the same time, many of their submissions didn't even run. So we had this problem of just reproducibility, right? And so this year we decided to have something that's reproducible, something that people can run on their own machine as well, so that if it works locally, then it works on the platform. And the third thing was what ended up happening was a lot of participants, they also removed their code. And one of our main requirements was, hey, you need to also provide your code, right? So as soon as we published the leaderboard, they removed their code. And when we reached out, they're like, hey, sorry, we actually want to publish a paper. So that's why we removed it, which is totally understandable. But then it did violate our rules in a sense, right? So when we reached out, they did provide the code. So we thought, hey, let's keep something that's simple, which is reproducible, and it's open, right? Because the entire point of research is that other people can look at what you've done and then improve upon. Right? And so this year we decided to use GitHub Actions because it's super simple. If to submit, you actually have to create a PR, so which is open, where people can critique your code, and where we can also critique people's submission, and even the results. It's whatever's computed, it's available to everyone, right? So if we move to the next slide, yeah. So the way this repository is structured is that we actually invite people to create a fork and then make all the changes to this submission folder. So you have to modify model.py, and you can also add any other requirements that you want to, and maybe external, because the second category, it's logical detection. So an example of logical anomaly would be, say you have a ketchup bottle, right? So it's internally the content is red, or you expect it to be red, but then it says mayonnaise on top, right? And you would, and any human would be like, hey, there's probably some mismatch here because it's probably mislabeled, right? And that's what this particular challenge is trying to aim at. And again, like Simon said, shout out to the MBTech folks. Two of them are here for creating this data set. And in Anomaly, we have actually integrated all the data sets. So if you use Anomaly, you can just download MBTech logo and also MBTech 2. When it comes to the challenge, we already have the data set on the server. So, I mean, we just fetch it from there. But what we invite the participants to do is actually create models that work on few shot settings, and use those sample images to then identify all the other logical anomalies. And the most common approach is using VLMs, right? Because they have some really good expressive power. And when it comes to just feature extraction, and also you can do a little bit of prompt engineering to retrieve the results you want. So when it comes to submitting, you just fork the repo, create a PR by making changes to this folder. And if you go to the next slide, you'll see that everything is then taken care of by GitHub Actions. So as soon as you create the PR, it will run a couple of checks. So we have few security, obviously, but then as soon as it finishes, if it's successful, there'll be a comment that'll be added to your PR, which will then have per category, like this is the raw metrics. And then at the same time, we push the results to a different branch, which is basically we are hosting the challenge through GitHub pages. So even the platform itself is, if anyone wants to host their own challenge, they can fork it. So it's hackable in that regards. So, in true open source fashion. And yeah, as soon as it's done, you can go to the link that's here and you can see where you stand.
That's great. I think that, and I want to say congrats to you and Ashwin and Dick and Samet that you are working hard on this. We have been facing too much challenges last year making the evaluation, and I'm glad that you find a pretty well solution and transparent. So so how many submissions have you received so far?
That's a good question. Actually, over here you can see 4 external submissions, and I don't know when this was added, but probably if you click on the link, you might see a few more.
Yes,
so there's one more. And of course we log the timestamp and the commit hash.
So that's great. So I will paste this link in the chat so people can see the leaderboard, and also I will paste the repo so people can see this one as well. This one.
There's one downside of this transparent approach. Obviously, some people may not want to show their results and code well before the deadline. So they just add some baseline methods here. But I expect significantly more submissions towards the deadline, as right before the deadline, because people may not want to reveal what they did.
It's okay. We try to be real on this show. Engineers are lazy.
That's normal. So we are just keeping everything to the end.
Yes, what we
Yeah.
see with so OpenCV currently has the perception challenge for bin picking, which is also part of our CVPR workshop as well. And we saw the same thing where people were kind of keeping their submissions a little closer to their chest. So what we did actually was introduce a weekly leaderboard prize, and they started submitting more. So we'll probably continue that next time we do one of these ranked challenges. We got a
That's
couple of
clever.
questions here for you all in the chat. Someone would like to know, can this be run in VS Code locally after creating a branch, or is it maybe a little too tough to run on your own machine unless you've got some real beefy hardware?
Yeah, so ideally you can, but you do need the hardware. It really depends on your model, because you can just run UV eval if everything is set up correctly. And if you set up UV correctly, then it should also create your environment, everything. So shout out to the UV folks as well for creating a very good tool. But you can run, and that's the whole idea, that if it runs locally, that is another guarantee that it's going to run online. The only challenge is, of course, if you have, like Phil mentioned, if you have a beefy model and your current compute does not allow it, then that's a problem. On the server, at least, we have for each basically runner, we have a 3090 and I guess 122 GB RAM attached. I don't remember exactly, but and those are the constraints that are also written in the rules. So this to also balance between, because there are some models, I think last year, which took a couple of days to run. And what we're trying to balance is, even if you have the best model, it's not really going to be used in industry if it is this slow, especially for inference. So that's the balance here.
Yeah, that makes sense. We got another question here. How many submissions are allowed by teams in this challenge? Because you've got to constrain it on some way, because that compute ain't free, right?
Yeah, maybe I can.
Yeah.
You want to start? Yeah, go ahead.
No, sorry, go ahead.
Yeah.
So at least I can speak for challenge two. So I don't want to speak for you guys, Lars, but at least for challenge two, right now, we have no limit. And as you can see, I guess probably everyone is saving till the end. But we did mention in the rules that if we do find that people are running a bunch of, or creating a bunch of different PRs, or is by the same team, then we might limit it, right? And again, in GitHub is actually straightforward. So you just have to, instead of running all actions immediately, you can just approve, and that's how we plan to limit it in case someone abuses it. But right now it's trust.
Makes sense. Makes sense.
So Lars, what about the MBTech, the challenge one?
Yeah, exactly. So for track one, it's a little different. We allow 2 submissions per week. So the earlier you start, the better. And the reason for this is, we want to make it as hard as possible to fine-tune on the actual test data. I've talked about this. It's non-public, so you only get to see the images. However, the ground truth is non-public. It's privately stored on the evaluation server. Because this is also something I think Summit, we talked about this already. You want to go ahead and talk about this, or should I?
What was that, sorry?
You want to go ahead and talk about cheating, or?
Yes, maybe. I can talk about it. So again, MBTech one was great, and it pushed the state of the art and literature. But one of the main limitation was that it didn't have any validation set, and a lot of papers just used the test set as to validate their data set. And when you look at the performances, they were kind of test set based and high performance, but when you use them on the real world settings, or maybe like a slightly different distribution, the performance just miserably bad, right? So that's another thing I'm quite excited about in VTech too. So you guys have private test set right now, so we can actually evaluate the real performance of the models.
Exactly.
Yeah, and speaking of evaluation, we've got another question here in the chat. Nidal would like to know, what are the evaluation metrics being used for both of these flavors of the challenge?
Yeah, maybe I can go first. For at least for track 2, we use F1 max score and image level F1 max score. So that's the one we'll be measuring.
Yeah. For track 1, it's also F1, but on pixel level. But again, we require this threshold estimation step.
Can you get a little more detail about like what those metrics mean for the folks who may be kind of casual viewers of this?
Sure. Again, if you don't mind, maybe I can just go first and you can correct me. So when it comes to anomaly detection, right, we deal with a lot of imbalanced data set. So we have a lot more normal samples compared to abnormal samples. So one of the ways to deal with that is to use precision and recall. And F1 is basically incorporates both of them. F1 max is basically using the threshold which gives the highest F1 score. It's the TLDR. Maybe you can go ahead.
Yeah, no, perfect. So for track 1, it's quite similar. Also F1, like the harmonic mean, or it incorporates both precision and recall. So regarding localization, it's important that you have a lot of true positives and as few false positives as possible, and also as few false negatives as possible, so on and so forth. And F1 just incorporates precision and recall. So this is like a good trade-off to measure all these characteristics a model should have.
Yeah, it's basically, if you have false positive, F1 penalizes it so bad. So like, what do I mean by false positive? It's basically if it's an anomaly-free image, but your model say there's an anomaly here, it's false positive, and F1 penalizes it so bad.
Yeah, that makes sense because your goal here is not to discover which models will perform best against the test, really. It's to find out what the best sort of broadly generalizable thing is in the current status. Like you don't teaching to the test is not very useful here, nor is it very useful elsewhere.
That we are almost done, so let me just play this video where we have how people can use Anomaly for both categories. So we have category 1. Samit, do you want to take this over to me?
Yeah, you can go ahead. Or should I go? I mean,
yeah, so
basically
you
just
can explain the API of Anomaly.
Yeah, so Anomalib has both MVTech AD2 and MVTech local datasets. And here you can see you can use Anomalib, import MVTech2 dataset, and you would have access to both private test set and the public test set. For MVTech local dataset, again, it's similar. You can import MVTech loco and whatever the model you want and just test the model. It's just few lines of code with Anomalib that both categories would be possible to solve.
That's perfect. Thank you. Thank you, Samit. So we have been doing a lot of efforts here. So we have been, organizing this event together. So try to find the best way to create the submission and evaluation for every single solution. And also we are making a monetary effort to prize people in the challenge. We have a grand prize for each category of $550 per winner. So we have these 2 first places with that prize. And also the invitation to present their solutions during our workshop. So the idea is to have a short video of 5 minutes to explain the solution. And also the winner will have the chance to publish a detailed blog in the Voxel 51 blog webpage, and also be part of the Voxel 51 meetup as a speaker explaining the solution. And for the second place, we have also this prize is so the The second place will be the wireless mouse for each of them. And the winner will have a chance to publish the blog, similar than the first place, and also be part of the Voxel 51 meetups. So we are trying also to bring a lot of people together in the community. I think that we need to have more of these kind of solutions in the field. And it is great to provide this visibility. I also want also to add that all of these things is open source. So you don't need to pay for this. You don't need to pay for subscription. So, everything that we have been talking here is open source. Anomaly, Voxel 51, so people can access NVTech AD2 for non-commercial purposes. Researchers, I think that will be great. If you can explore or create a pilot for your solution, you can also do that. And this is the way that we can democratize AI. And this is really important for all of us. So what is next? We want to invite you to register to the challenge, join our community, and submit your solution to the track 1 or track 2. And connect with us if you have any questions about the challenge. I think that you can find us also in LinkedIn, but the best way to connect with us in the challenge is in the community, in the Discord channel. So I think that with this we are closing almost on time.
Fantastic. Yeah, no, we got all the time you need. But let's take a moment here to do our trivia giveaway, if you don't mind.
For sure.
Go ahead and unshare your screen there, if you will. And we will pull on up to the pay window here on OpenCV Live. An exciting challenge. This is the third one of these, and I think this is the third time we've had you on the show to talk about it. Isn't that correct?
Is that correct?
Yes. So, folks, one of the things we do here on OpenCV Live is give away something to you in the audience. In a moment, I'm going to ask a trivia question based on today's presentation, and the first person to answer it correctly in the Zoom chat with their messages set to everyone and not just hosts and panelists will win the OpenCV University course of their choosing, or if they're in the Bay Area, they can choose to get a free pass to OpenCV's conference OSCA on Monday, May 12th. If it was me, I would take the free pass. But before we do that, let's talk a little bit about OpenCV and why it is important to support OpenCV. As I said, we've got OSCA coming up this May 12th. Please check it out. You can go to the displayweek.org website. We've got a promo code for you as well on the Hackster website. If you use code HacksterLove, that's 20% off of the full price here, and you'll get to see some of our awesome speakers like Gary Bradsky, Satya Malik, Ethan Rubley from Space NG, who just helped land a rover on the friggin' moon, and it's the one that worked, not the one that fell into that crater. Super excited about that. But you can also donate to support OpenCV individually via Stripe or PayPal by going to opencv.org/support. Or if you work for a large organization like a Microsoft or a John Deere, you can also possibly get matching donations from your company. Talk to your boss about matching donations using the Benevity Causes portal. We love to see that. It's a small amount of money OpenCV gets from these every quarter, but we do get some, and it really means a lot to us and helps keep the lights on here, so to speak. Individuals can donate via Stripe or PayPal. Also, if your company uses OpenCV heavily and benefits from it, consider becoming a member organization. We have 3 levels of membership here: bronze, silver, and gold, created for companies of different sizes with different abilities to give back to the community. We really appreciate all of OpenCV's members. You can also sponsor OpenCV on GitHub. We've got 13 sponsors over there right now. Check that out at github.com/sponsors/OpenCV. It's $9 a month. I'll give a quick shout out to the 13 right now. We've got LivePeer, DJ Greenwood. I'm starting to recognize some of these faces. Rudis Laboratories, Talib Hussein. We've got the homies at RoboFlow. Brian Bjark Jensen. We've got Alexander Ismailov. We've got Comet ML. We've got Jonas Heinle, or Jonas, I'm not sure which. Nick Libertini. We got Blue Jay. We got Jesus. And we've got Victor Vedavato. Thanks so much, everybody, for sponsoring us over there. A couple other things. OpenCV is also running a challenge right now with a ranked leaderboard. We just closed out the development phase of the Perception Challenge for bin picking. That's bpc.opencv.org. And we made a big change for phase 2. Originally, we had said you cannot participate in phase 2 of this if you had not submitted to phase 1. We have changed our mind after a lot of feedback from the community. You can now do that. We had, it looks like 45 submissions for phase 1. The top of the leaderboard there was SEU, WIL trained, SSMP. As you can see, the MAP, which is the main score here, very close together at the top. We are now in the testing phase. Just a few teams have submitted so far in the testing phase. Just a few days left to submit these. And as you were talking about earlier with your challenge, I anticipate that the last couple days we will see a lot of submissions. But, you know, hey, folks, there is a time limit on these, so get your submissions in early. I want to give a quick shout out to our friends at Zeiss, one of the legendary optics manufacturers in the world. Recently had a great conversation with Nicholas from Carl Zeiss AG. They chose OpenCV as one of the open source organizations to receive a small grant from them. They sent us a check for a couple $1,000s, and we really appreciate that. Zeiss is legendary for a reason. Medical technology, cameras, pretty much. If you own one or more devices that takes photographs or shoots video, one of them probably has some part of Zeiss Optics in there if it's any good. So thanks so much for them. There's the funding that they sent us here. Hopefully we can do some more stuff with Zeiss. You can go ahead and check out that link. I will drop this link in the show notes as well. Yeah, you can also buy OpenCV merch. We've got t-shirts, we've got buttons, we've got hats for some reason. You can also buy little pet bandanas to put on your dog or a small child. They all kids kind of look the same. Put a little OpenCV bandana around your kid's neck. You can tell them the difference when you take them to daycare. It's just a safety issue. You can also buy the I Love OpenCV design on t-shirts, on tote bags, etc. In English, simplified Chinese, and en Espanol for the Spanish speakers out there. And of course, we've got the Import CV2 Classic shirt there and the OpenCV logo. Yeah, so help us out. Give back. OpenCV will be at Display Week all week next week. The May 12th is the OSCA event, but after that we will have an awesome giant 30 by 30 foot pavilion on the exhibit hall floor for Display Week from May 13, 14, 15. We will have some freebie OpenCV stickers available there, the OSCA sticker as well as the I Love OpenCV sticker, perfect for adorning your laptop or backpack or whatever you got there. So now comes the trivia. As I said before, the very first person to answer today's trivia question in the Zoom chat with their messages set to everyone, not just hosts and panelists, will win the OpenCV University course of their choosing. You can see what courses are on offer by going to opencv.org/university. Tons of good stuff over there. And even if you don't win trivia today, maybe invest in yourself, upskill, get a new job, get paid more at your current job with OpenCV University. Industrial grade courses from the industry. So I have a feeling y'all are going to answer this one in like less than 1 second. Let's see. If you've won in the last couple of months, please do not answer and give someone else a chance to win. So we talked a bit today about a couple of CVPR workshops. OpenCV has one. The VAND Challenge has one. On what date do those workshops occur? Don't let me down, chat. No, you're so close. Srijan, that is the OpenCV OSCA conference. That is not the CVPR workshop. CVPR. Oh, there we go. I see Matha Gorham, one of our YouTube members. In fact, thank you so much, Matha. The correct answer we were looking for there was June 12. Some of you got hung up on May 12. No, the answer was June. Congratulations to Matha. Please send one email to phil@opencv.org with the course you would like, and we will see that you get that course. Congratulations, and thank you for paying attention or Congratulations for having the fastest fingers out there and remembering the URL. Paula, what else you got? You got anything else for us today?
No, I think that this is something that we want to keep people updated with everything that we are doing around computer vision. So we have this challenge, but more things are coming to the plate. So stay tuned because more things are coming. So we are doing a lot of stuff in different industries. We have manufacturing, healthcare, agriculture. You know that I'm working in agriculture. So and that will be great to see more people interested to participate in this challenge. If you want or your company wants to add more money to the prices, that will be great. So we are also having conversation about the sponsoring. If you want to participate as a sponsor, that will be great. We can add more money for the first and second places. So that's all. And thank you, Phil. Thank you for the invitation. This is really good to stay here in the show. OpenCV is my favorite library after 51.
Hey,
And
you know what
Anomaly,
side your
I
bread,
mean,
you know what side your
I'm,
bread is buttered on.
right now I'm feeling in trouble, Summit. So Anomaly as well.
Yes.
So it is
Well,
great to have.
OpenCV always the first one though, right? So all of us started OpenCV.
Yes,
Namaste.
I think that
Thank you.
I started with OpenCV before we changed the name of image processing. That we will talk about image
Improv.
processing and fuzzy logic. So I was using OpenCV, and I was reading the Satya courses as well. So this is great to see the evolution of OpenCV, and I'm a big fan of the library, no doubts.
Yes. Thanks so
Thank you,
much, everybody.
Phil.
Yeah, I'll just do a quick gallery view here. Yeah, say goodbye to the folks out there. Thanks so much to all of our guests here. So many faces in the guest list today. We really do appreciate it. Yeah, take care of yourselves out there, folks. Take care of somebody else if you can, and have a great day wherever you may be. Adios.
Mhm.